Chemistry lecture number 104, Oxidation Reduction. Oxidation reduction, aka redox reactions. This is a chemical reaction where electrons are transferred from one atom to another. Now in the above reaction, 2 electrons, sometimes abbreviated as 2E, are transferred from the bromine ions to the chlorine molecule. So here's 2 bromines, each bromine's holding an electron, and then after the reaction, the chlorine atoms are now holding the 2 extra electrons. So bromine loses the electrons as it goes from here to here. The 2 bromine ions combine to form a bromine molecule, but each bromine ion gets rid of an electron and it goes somewhere. So the bromine loses electrons, which means the bromine has been oxidized. The chlorine gains electrons. If you go from here to here, you notice that we have a chlorine molecule made of 2 chlorine atoms. After the reaction, we have 2 chlorine ions. Each chlorine ion contains an electron, so somehow the chlorine was able to steal 2 electrons from somewhere. So the chlorine gains electrons, and that means that chlorine has been reduced. An oxidizing agent is the substance that steals electrons. Chlorine steals electrons from bromine, or chlorine oxidizes bromine. Chlorine is the oxidizing agent. Reducing agent is the substance that donates electrons. Bromine donates electrons to chlorine, or bromine reduces chlorine. Bromine is the reducing agent. Chlorine oxidizes bromine and becomes reduced. Bromine reduces chlorine and becomes oxidized. The oxidizing agent is the substance containing the element that's reduced. The reducing agent contains the element that is oxidized. To identify oxidizing and reducing agents, we need to know the rules for finding the oxidation numbers of atoms in a compound. So here are the rules. The oxidation number of atoms in a free element is 0. So for example, the atoms in zinc, hydrogen, sulfur, and oxygen all have oxidation values of zeros. So these are all elements. All right? So if it's in the elemental state, the atoms in the elemental state have oxidation values of 0. Oxidation number of hydrogen is always +1. Remember, that's when it's combined with something else, when it's part of a compound. For example, for H2S, H has an oxidation number of +1. All right? So in the non-elemental state, hydrogen is going to have an oxidation number of +1. Now most of the time, the oxidation number of oxygen is -2. So for example, in H2O, oxygen has an oxidation number of -2. But in peroxides like H2O2 and Na2O2, oxygen has an oxidation value of -1. So these are just the exceptions to the rules that you just have to memorize. The sum of the oxidation numbers must equal the charge on that compound, and we'll show an example of that in an upcoming problem. The oxidation number of aluminum is +3. The oxidation number of group 1A elements are +1, and group 2A has a value of +2. So let's try a problem. What is the oxidation number of the elements in Na2SO4? Well, here's how you do it. Sodium is a group 1A element, so sodium is going to have a +1 oxidation value. Oxygen, remember the rules say oxygen has a -2 oxidation value, so O is going to be equal to -2. Now, since the sum of all the oxidation numbers must equal the charge on the compound, we use algebra to find the charge on sulfur. Na2SO4 is a neutral compound, so the total charge is 0. So Na2SO4, there's no negative or positive sign written around here, so it's a neutral element. The total charge is 0. So the way we're going to do this is we're going to list all the elements that make up the compound, sodium, oxygen, and sulfur, and we're going to use these to sort of represent the charge contributed by each of these elements. And when you add up the total amount of charge, it's equal to 0. All right? So sodium, and in place of sodium, I'm going to write 2 because there are 2 sodiums, Na2. All right? And then sodium is a +1 charge, so it's going to be 2 times +1. All right. And then for oxygen, well, here's oxygen. There are 4 oxygens. So it's going to be 4 times the charge on oxygen, -2. All right, so 4 times -2. And then the amount of charge contributed by sulfur, we don't know, so we'll just leave it as S. All right, well, if you do the math, 2 times +1 is 2. 4 times -2 is -8. And then 2 plus -8 plus S is 0. So in order for all this to equal 0, the charge on sulfur has to be equal to 6. So that's the charge on the sulfur. All right. So we have it for the oxygen, we have it for sodium, and we just solved it for sulfur. All right. So that's the answer. What is the oxidation number of the elements in Cr2O7? Now this one has a -2 charge. All right. Well, once again, oxygen is going to have a value of -2, and the sum of all the charges in the compound also is equal to -2. So when you add up all the charge contributed by the chromium and the oxygen, it's going to add up to -2. See the -2 up here? All right. And we can use algebra to find the charge on chromium. So Cr is the charge contributed by chromium, O is the charge contributed by oxygen, and the total amount of charge is -2. That's that number right there. All right. So for chromium, since there's a 2 here, Cr2, we're going to put a 2 in front of it. We don't know how much charge it is, so we're just going to write it as 2Cr. For oxygen, 7 oxygens, so it's going to be 7 times the charge of oxygen, and then equals the total charge on the whole compound, -2. All right, so we're just going to solve for Cr then. So 2Cr, 7 times 2 is 14. And so since it's a negative number, it'll be -14 equals -2. If I add 14 to each side, you'll get 2Cr equals 12. And then Cr, divide both sides by 2, and the charge on chromium is +6. All right. The change in oxidation number of atoms allows us to identify oxidizing and reducing agents in a reaction. Identify the oxidizing and reducing agents in this reaction. Now we're going to ignore the coefficients in front of the each substance. So we're going to ignore the 3 and the 2 and the 3. We only want the oxidation numbers of the products and reactants. So I'm going to write the oxidation of the number of the atoms above the substances. All right. So here's how we do it. Oxygen is going to have an oxidation number of -2. So I'm just going to write in the ones that we know. All right. And here's another oxygen. That's going to have a -2 charge, so I'm going to write -2 here. Iron, that's elemental iron. All right, so the rules state that the oxidation number of atoms in the elemental form is 0. So the oxidation number of iron here is 0. And then once again, oxygen has a -2 charge. All right, now when we originally started, this was a neutral molecule. So that means when you add up all the charge, it has to equal 0. So oxygen has a -2 charge. 3 times -2 is -6. So what does the charge on iron have to be to cancel the -6 charge that we get from the 3 times -2? Well, the charge on iron is going to be +3. 2 times +3 is +6. +6 plus -6, -2 times 3, is going to be 0. So the total charge is 0. So I can, sort of do that here. Okay, so the total charge is going to be 0. So the charge on the iron is +3. We'll go through the same procedure for this one here. So this was originally a neutral molecule. The total charge is 0. We know oxygen has a -2 charge. If oxygen has a -2 charge, then the carbon has to have a charge of +2 so that the sum is equal to 0. Okay. So 2 plus -2 is 0. This one's all set. And then we can do this again. Again, carbon dioxide is a neutral molecule. We know that oxygen has a -2 charge. For oxygen to have a -2 charge, that's -2 times 2, that's going to be -4. So to balance the -4 charge, this carbon has to be +4. Okay, so those are the oxidation numbers of all the atoms in the compound. Now, I want you to notice something. If we pay attention to what happens to the iron, here to here, Fe2O3, just going to put this out here, +3, -2, and it becomes, so this turns into that basically. Now notice that the iron in the Fe2O3 changes its oxidation state from +3 to 0. Alright. And thus the iron atom has gone from +3 to 0 here. It's stolen 3 electrons. Fe2O3 is the oxidizing agent. Alright. Okay. All right. Let's see. And then let's take a look at the carbon dioxide here. So let's see how that changes. So it's going to be CO, and it's +2 and -2, turning into CO2. And this is going to be +4 and -2. So you notice that the carbon in CO right here changes its oxidation state from +2 to +4. All right. So the carbon atom has gone from C2+ to C+4. So atoms gain positive charge when they lose electrons. The CO is the reducing agent. It's donated electrons to the iron atom. So this is the reducing agent. Okay. I don't know if you saw it previously because I didn't have this adjusted right. Just to show it back here. For the iron, the total charge is 0 because 2 times 3 right here is 6. And -2 times 3 is -6. So when you add these together, the total charge here is 0. Sorry that wasn't visible the first time. Okay, well anyway, that's how you figure out the oxidation numbers, and knowing the oxidation numbers, you can figure out the oxidizing agents and the reducing agents. For a PDF transcript of this lecture, go to www.richardlouis.com. This has been Chemistry Lecture number 104, Oxidation Reduction.